Hey, Nathan here. Welcome back to another MonoGame Advanced video. And in this video we are going to discuss implementation of a sprite sheet. And this is going to be a very basic implementation. We'll extend on this the more we go into sprite sheet. For example, how to do per pixel collision detection when you're in the middle of a sprite sheet animation. And kind of just wrap things up on how to restart sprite sheets and make it move slower. The animation will move slower. So this is just the groundwork on how to get started on sprite sheets. So the way that we are going to set this up is that our sprite sheet is one giant texture. It is a photo here. So we are going to set this up to break these. This is one giant texture. So we're going to break this into an array of textures. This image is going to be one texture. The next image is going to be another separate texture. Each one of these components of the sprite sheet is going to be its own dedicated texture. Instead of having this in one giant texture and then just moving a rectangle to where the current frame is, we can break these apart into a texture array that represents our entire sprite sheet. So you can do this both ways. You can have one giant texture and just move the rectangle on where it's drawing. Or you can do this another way and just separate all these into their own dedicated textures. Depending on your memory limitations, or depending on how many sprites in your game and how many frames you want in your sprite sheets, that might play into a factor on which one of these methods you want to go. Obviously, having each one of these have its own memory component will be a lot more memory intensive than having one giant texture. Before we get started with the actual implementation of our sprite sheet class, we need to create an extension method of the texture 2D in order to get the RGBA values of every single pixel in a two-dimensional array. That'll be a two-dimensional color array. But we're going to extend on the one that's pre-existing, and it's going to be a generic extension method. So let's get started with that. So let's right-click our sprite sheet project. Let's go to Add, and go to New Item, or just Class. Just add a class. And we're going to call the class Texture 2D EX, or whatever your standard naming convention is for extension methods. It's going to be a public static class. So public static class texture 2D EX. And then the get data method is going to be a static as well. Public static void get data. T, that makes it a generic method. We can pass anything T and we will constrain it to a struct at the end of this method declaration. So it's going to be T, open parentheses, this texture 2D. We're going to import Microsoft.xna.framework.graphics. So this texture 2D texture, comma, T, opening bracket, comma, closing bracket, space data. Alright, at the end of the parentheses, type in where T colon struct. So we're going to constrain T to be a struct type. That includes our color value, which we're going to get data by a color. So we provide T. We need to use T in our method. T is going to be passed whenever we call get data. So we don't know what T is at the moment. T, bracket, closing bracket. So we're going to get the one-dimensional array. So data one dimensions is equal to new T. We don't know what T is, but we can call new T. Texture.width times texture.height. We're doing exactly the same thing that we would have been doing if we were getting the color data in a one-dimensional array. So we just call texture.getData. That just gets data in the one-dimensional array. Data, 1 dimensions. So we want to convert that data to 2 dimensions. So in order to do that, we have 2 for loops. For int x is equal to 0. X is less than texture.width x plus plus. And the inner for loop is the y component. For int y is equal to 0. Y is less than texture.height y plus plus. So that is going to break our one-dimensional array into 2 dimensions by having 2 for loops. So we get the x and y component in the for loops. So our output data up here, data here, data bracket x comma y closing bracket is equal to data 1 dimensions bracket, just like we do with per pixel collision detection, x plus y times texture dot width, and then semicolon. So data x comma y is the equivalent of the data in 1 dimensions by using this mathematical expression. X comma y is the same as x plus y times texture.width in a 1-dimensional array. If you don't want to use this, you could just use a 1-dimensional array by just doing this. Okay, so that is our extension method. We can save that. Now let's work on our Sprite Sheet class. So let's right click our Sprite Sheet project. Let's go to Add Class. And let's call this Sprite Sheet. It's going to be a public class. Public class Sprite Sheet. And we're going to have some attributes here, like the asset name of our master sprite sheet, the one that has all the frames, the frame height, and the frames in X. So let me explain that. So frame height is going to be the height of a single frame. So let's say 60 pixels. So this image is only 60 pixels. No, we need that, and we need the second component for frames in X in order to determine when it jumps to the next row and when it jumps to the next row if there's more than 2 rows. So we pass in like 60 pixels for the height and 1, 2, 3, 4, 5, 6 for the frames in X. Then we have the array of the textures, which every one of these parts of each frame of the animation has its own dedicated texture. So obviously we need an array to hold that. Then we also need the frame width. Not only do we need the 60 or whatever for the height, we need like 30 for the width. And then we need total frames. You know, is this whole thing 11 frames or 20 frames or 1,000 frames? That needs it, because if you have looping enabled, once it hits that 10, 11, 12, 20, 50, 100, 1,000, once it hits that frame number, if you have looping, it will reset, and if you don't have looping, it will say this animation is finished. Which is also why we need 2 more things. We need a boolean for is this a looping animation, and we need a boolean for is this animation finished. And then we need to hold our master, you know, we need to hold this texture. We need to hold the texture that has all of the frames in it, not just the ones that are broken down in its own, each separate texture. So all those need to be attributes. A lot of them will be read-only. We will just set it in the constructor, and it should never change. If you need it changed, you have to create a new class, a new instance of that class, and to change the height and the width. So a lot of these will be private and read-only. Well, all of those will be private. Most of them will be read-only. So private read only string underscore asset name. That holds the name of our giant texture with all of our frames. Let me move my mouse there. Private read only int frame height. Private read only int frame width. So the width and the height of each individual frame in our sprite sheet. Private read only int frames in X. How many frames we have in each row. Private read only texture 2D. That's going to be the array, not extension. Texture 2D, so we need to add using Microsoft.xna.framework.graphics. So that's going to be a texture 2D array and frame textures. Alright, then we need the total frames. So private read only int total frames. Alright, now we need private fields, but they should not be read only. So private bool underscore loop private bool is finished. Okay. Alright, the last thing is up to you if you want to keep this. It's not really necessary. It's going to be private texture 2D. And it's going to be the sprite sheet of every frame of that sprite sheet. So the master sprite sheet. That's not really necessary. We're only going to use it once. So if you don't want to hold on to that reference, you can just create that during the method that's going to break the sprite sheet into multiple frames like here. So that's up to you if you want to keep that or not. Alright, now for the constructor. Public sprite sheet string asset name int frame width int frame height int frames in X int total frames bool loop is equal to true. We're going to default that to true. And let me put that on another line here. Okay. So that is our constructor. Now we need to set our private fields up to what we passed in the constructor. So underscore asset name is equal to asset name. Let me move the mouse again. Underscore frame width is equal to frame width. Underscore frame height is equal to frame height. Underscore frames in X is equal to frames in X. Underscore total frames is equal to total frames. And underscore loop is equal to loop. And then we need to set underscore finished is equal to false. We just started, so it's not finished. Alright, I'm actually going to delete that white space there because I'm going to create a white space for this down here. We need to initialize the underscore frame textures, and that's going to equal to new texture 2D, and that's going to be the total frames. We only need to have the array be the length of the amount of frames we have. There's no reason to have it any more, and if we have it any less, we'll get an array index out of bounds. Okay, so all these are private. How do we get, if we want to receive information from our sprite sheet, like what's the current frame? How do we get that? Let's set up a public property, public int frame, get and then private set. So that's going to be a public property that's accessible to anywhere we create an instance of this. And then in the constructor, let's set that property to 0. We're going to start at frame 0. Okay, now if we have a collision class, how are we going to perform per pixel collision detection if we cannot access our frame array, let alone our current frame? So let's create another public property, public texture 2D current frame equals angle bracket underscore frame textures opening bracket frame. So that's going to return the texture at index frame. Whatever our current frame is, it's going to return that from the array of textures at that index, and then we're able to receive it in our per pixel collision detection algorithm or wherever we need to find that information. Okay. We have our asset name, and we have a texture to hold that asset. Now we need to create a load content method. So public void load content. We're going to pass in the content manager and we need to pass in the graphics device. So those two need to be passed into our load content. So if string.isNull or empty underscore asset name, we cannot load an empty string. So we cannot continue with our implementation of this. So let's throw a new null reference exception. Underscore asset name must not be null or empty. Okay. So that will exit that method. It will throw an exception, and if we're doing proper exception handling, it will not crash our game. It'll just throw up a message saying we cannot load your class, load your asset. Now, if we cannot continue, go ahead and let the game crash, because we cannot continue. This is an example. We cannot continue, so crash the game and throw it in a log file or something like that. So underscore sprite sheet texture. So equal to content.load. It's going to be a texture 2D. And it's going to be underscore asset name. We know that that contains some data because we didn't throw an exception, so it's continuing the method. Okay, so now we're going to call another method here. Break sheet into frames. And we're going to pass the graphics device. So break sheet into frames. Let's create a new method for that. It's going to be a void graphics device. Okay. So this method is just going to take care of breaking that sprite sheet into multiple frames. Alright, so a color array, opening bracket, and have a comma there. That's going to be multi-dimensional array. And be sure to add Microsoft.xna.framework for that. And let's set that to be called sprite sheet texture data is equal to new color. So we need to pass in the width and the height, the x comma y, so underscore sprite sheet texture dot width comma underscore sprite sheet texture dot height. Okay, so that's the multi-dimensional array. Now we need to provide the getData method call. So underscore sprite sheet texture dot get data, and we're gonna provide our sprite sheet texture data. So that gets data and populates it into a multi-dimensional array. For int current frame is equal to 0. Current frame is less than underscore total frames. Current frame plus plus. So this loops through all of our frames. This is why we also needed to provide how many frames our entire sprite sheet has. So underscore frame textures, open bracket, current frame. We want to get that index. I'm gonna set that. And now we need to provide another method call, get texture from frame. We need to provide the sprite sheet texture data, current frame, and graphics device. Alright, let's go ahead and create that method. It's going to return a texture 2D. Yeah, all these are fine. Okay. So this is going to be a pretty big method here. So let's create a new one-dimensional color array. Color, opening closing bracket. That's going to be our frame color data. It's equal to new color underscore frame width times frame height. So why are we using a one-dimensional array for our frame color data? The texture has a setData method that I did not extend, so it only accepts the full one-dimensional array instead of a multi-dimensional array. So texture 2D, that's going to be our frame texture, is equal to new texture 2D graphics device, comma underscore frame width, comma underscore frame height. So we needed to provide the graphics device to this method because when we create a texture 2D manually, we have to provide that. Okay, so let's set up we're going to set this up to where it's going to have two for loops to loop through our sprite sheet texture data, the X and Y components in that. We also need to have two other variables to hold our frame X and Y values, which are obviously going to be separate. The frames X and Y will start at 0, 0. But remember, our sprite sheet texture has all of our frames in it. So we could be looking at the last frame, which would be 320, 560. It's going to start there, but our frame is going to start at 0, 0. So we need to have two other int values for frame X is equal to 0 and frame Y is equal to 0. I'm just going to call those fx and fy. Now we need to get the current x and y. We don't provide that information. All we provide is the current frame. And our class holds our frames in x and our frame width and our frame height. So we can get the x and y values of where we're supposed to start based on that information. Int x is equal to current frame %, we're going to get the modulus result of this underscore frames in x. So let's say our current frame is 1 and we have 10 frames in x. Every row has 10 frames, a max of 10 frames. So 1 modulus 10, that will give us a result of 1. Now we need to multiply this by underscore frame width. So that makes sense. Our first frame is going to be at index 0. Our current frame will be at index 0. So our values are going to start from 0 and go to the frame's width. Now our second frame, which is index 1. So 1 modulus frames in x, let's say that's 10, that will give us 1. So we push that segment over to the right. So now we're starting at the frame's width, which in this case, let's say it's 100. So we start at 100 and then we go to 200. And then we load all the textures in that range, 100 to 200. And then we repeat the process. We move that segment depending on the current frame. We need to do the similar thing for y, but we need to use division in this case. So int y is equal to current frame divided by frames in x times underscore frame height. So let's say we have 10 frames in x. If our current frame is 11, so 11 divided by 10, that's going to give us 1. It's integer division, so that's going to give us 1. We don't care about decimal. We don't care if it's 1.1, 1.5, 1.9. It's going to be 1. And then we'll multiply the height, because just like how I explained in the x, we're doing that in the y component as well. We're moving that segment vertically, pushing it down. Now we need to provide the end x and end y, which is just adding the x and y components by the height and the width. So int end x is equal to x plus the frame width. Int end y is equal to y plus our frame height. Alright, so now we can generate our two for loops. So for int color y, we're going to have y as the outer loop. So color y is equal to 0. Color y is equal to y. We need to start at where our current frame is in relation to our entire sprite sheet. So we start at y. Color y is less than end y. Color y plus plus. So that's our outer for loop. Our inner for loop is going to be x. So for int color x is equal to x. Color x is less than end x. Color x plus plus. Okay. So now we need to convert our multi-dimensional sprite sheet color array. We need to get the color value from that, and we need to convert that to a single dimensional color value for our frame. So frame color data, opening and closing bracket, fx plus fy times underscore frame width. Just like how we handle per pixel collision detection. That's going to be equal to the sprite sheet texture data. Now this is a multi-dimensional, so we can get x and y by providing color x, comma, color y. Alright, so once that is done, we need to increase our fx by 1. And that's it for the inner for loop. Now let's finish up the outer for loop. So fy plus plus. Now y is changed to the next row. So we need to restart x to the far left side. So we need to reset that to 0. Fx is equal to 0. Alright, last two things. That's after the outer for loop. We need to set our texture, frame texture dot set data, and that's going to be equal to our color data, frame color data. And then we're going to return our frame texture. And that is it for that method. Now, a sprite sheet won't do us any good if it just sticks at the 0 frame. It just displays the first index. So public void update. We're going to update our sprite sheet game time. And we're going to update if it is finished. We just simply return. There's no reason to update. It's finished. We're done. We will not be running anything else. So this is the very basic. This is the stepping stone where all we're going to do is increase our frame ++. In later videos, we'll discuss how to slow our frame animation down and how to manipulate this even further. But anytime this method is called, it will just increase our frame by 1. Now, what if we have 10 frames, but we increased it to 11? If frame is greater than or equal to _ total frames, we're going to go ahead and set up looping now because it's very easy. So if _loop frame is equal to 0. That's it. That's all you have to do to get looping going. Else frame is equal to _ total frames -1. It's going to be our last frame. Remember, we can have a sprite sheet with 1 frame, but our index needs to be 0. So 1 minus 1, that will be 0. _ finished is equal to true. Alright, that is it for our sprite sheet class. Okay. Let's go to game1.cs. So we have graphics device manager, graphics, sprite batch. Now we need to hold the sprite sheet. So private sprite sheet. Alright. Now we need to load that texture into our content. So I'm going to right click and open with. I'm going to choose the pipeline tool there. Okay. So here it is. So let's right click and add existing item. I'm going to go to my subversion here. It's going to be MonoGame Trunk Advanced Tutorial 10 Sprite Sheet Content. We're going to add the animation, our sprite sheet there. Copy the link to directory, yes. Okay, so we're going to create a copy of that texture in our project. Alright, now we're going to save, and we're going to build this. Okay, so we have that loaded. Now, in the initialize, let's set this up to have sprite sheet is equal to new sprite sheet player paper animated, and that image will be in the description or a link on the website, comma 58, and this is discovered in Photoshop or any image editor of your choice. Whenever you create the sprite sheet, you should have these values written down to know how big each frame is. So 58 by 86, and we have 6 frames in X, and our total frames are 11, and we will not want to loop. Alright, now in the load content, we're just going to call sprite sheet.load content. You pass in the content manager and the graphics device. Alright. In the update method, I'm going to set this up to wait until, let's say, 5 seconds or 10 seconds before our animation will start. So if GameTime.total seconds is greater than 5. If it's more than 5 seconds, then we will start animated our sprite sheet. Okay. In the draw method, we'll have sprite batch dot begin, sprite batch dot draw, our sprite sheet dot current frame, vector 2.0, and color dot white, and sprite sheet dot end. Or not sprite sheet, sprite batch dot end. Okay, that should be it. If we save everything and hit start, hopefully everything will be working fine. 5 seconds, that should start animating. There we go. Now, if I scroll up to initialize and I change that false to true, and if I start our code, 5 seconds it'll animate and it should loop. And it does. So that is the first dive into sprite sheets. Later on, we will look at how to slow things down to have more control on how fast the animation goes. And we'll worry about rotation and dealing with per pixel collision detection in the future as well. But this will give you an idea of how to start with sprite sheets. I chose the path where every frame in the texture has its own dedicated texture 2D instance. If you don't want to go that route, the other way is just as simple. It requires a little more mathematics, but we didn't have to go through the process of breaking these down like we had to in this video. Alright, so I hope you enjoyed this video. So our next video, we're going to discuss sound, how to get sound effects going and music going in MonoGame. So I'll see you next time.